Hello students, welcome back. Previously in section 1, we went through some terminologies such as antiderivative, indefinite integral, and of course the notation. We went through integral constants as well. Alright, now let's consider some techniques. Some antidifferentiation rules. Here are a couple, and these are both trivial rules. Antiderivative of 0 is a constant because derivative of constant is 0. Antiderivative of constant is kx because if you take the derivative here, x just disappears and then we just get k. One of more common mistake is doing this. Derivative of constant is 0. Antiderivative of constant is not 0. It is that constant times x. As you see here. Next rule. I haven't seen anybody having difficulty here. Antiderivative of sum is sum of the antiderivatives because derivative of sum is sum of the derivatives. And the same goes for coefficient. I have never seen any students having difficulty here. Nonetheless, I have some warnings. Antiderivative of product is not product of the antiderivatives. Yes, it works for addition. For multiplication, it doesn't. Remember the product rule? What's the derivative of What is the derivative of product? Is that it? Derivative of product is product of the derivatives? No, it's not. It looks like this. We had product rule. So the right-hand side is a heck of a lot more complicated. It's not going to be as simple as this. As for quotient rule, it's even worse. Antiderivative of quotient is not quotient of the antiderivatives. Same as the derivative of quotient is not quotient of the derivatives. The quotient rule is even worse. Nonetheless, I sometimes see this kind of answer. Be careful there. Okay, so much for trivial rules. Now let's talk about some rules that you're going to actually use. Okay, power rule. So if you take the derivative of power function, what do you get? Well, power comes out as coefficient and subtract 1 from the power. That's it, isn't it? So if you go backward, that's what you're going to get. Add 1 and divide. Here, multiply and subtract 1. Here, add 1 and divide, because antidifferentiation is inverse process of differentiation. It works every single time except for 1. When k is -1, this denominator is 0, so this entire thing will break down. And that's why we have the second rule down here. Let's see. What is the derivative of log function? It's 1 over x, isn't it? Or equivalently speaking, negative first power. So we have this rule. So for power function, in general, it works like this. Add 1 and divide 1. But when k is -1, we have log function. By the way, I like this rule much better than the alternative rule. Let's see. Yeah, this one here. because I've seen so many students making mistake here because they were fooled by this reciprocal expression. I see this kind of answer from time to time. Like this. Ooh. Like this. 1 over something, so automatically it's log. So another one. 1 over something, so automatically it's got to be log. Well, both are wrong. And if you focus upon this reciprocal function too much, you're going to end up doing these. And one of the best ways to protect myself from that kind of stupid mistake is to do this. Rewrite those into the power form. In that case, this one here, this red problem here, can be redone like this. X to the negative 1/2 power. And if I use this rule, what do I get? Add 1 to the power and then divide. Dividing by 1/2, so multiplying by reciprocal, but nobody writes like this. So this is right. Previous expression is wrong. And this one, think about how to correct it. This certainly is not right. And that's because you're focusing too much upon reciprocal expression. And the third rule, I don't have much to talk about the third rule here. Exponential simply states itself. That's the basic case. Now, we do have some time left, so let me talk a little bit about this expanded form. Although we don't need it right now, just yet. Okay, let's keep this open. Let's consider similar circumstance, except that instead of just x, we have ax plus b. Instead of just x, we have ax plus b. Again here, instead of x, ax plus b. And what's the recurring theme? We have 1 over a, 1 over a, 1 over a. Why is that? If you start from the right-hand side and then take the derivative. Oh, I don't have any proof here. Okay, all right. So, okay, all right, let's start from here. And then, what do we get? Let's see, plus c will just disappear because that's constant. And then that's just coefficients, so it'll stay the same. And then let's work this one out. Power function, so multiply by the power. And then subtract 1 from the power. And that's not all. By chain rule, I have to multiply the derivative of the inside. And what is it? That's a. So if I calculate everything, this k plus 1 and that k plus 1 will cancel each other out. This a and that a will cancel each other out. And do we get the integrand back? Yes, indeed. I get this one back. You can deduce the other same way. What's the recurring theme? 1 over a, in order to undo the chain rule. We're going to talk about this one in a little bit more detail in the latter part of section 2, so we don't need it right away yet. But please remember those anyway. We're going to do exercises about these first, and that's going to be the next video. And then the other problems will deal with, the latter problems will deal with a little bit more expanded situation. Let's stop here and let's say we are done with section 1 and let's meet again with section 2. There we're going to do some more integral computation.